Okay. Good morning, good afternoon, or good evening, everybody, wherever you may be. And welcome to this AWS Activate webinar. This webinar concerns developing on AWS. And this webinar assumes that you have a basic knowledge and competence on cloud computing and AWS. My name is Markku Lepistö. I'm a Principal Technology Evangelist at Amazon Web Services, working out of Singapore. Let's start by looking at a couple of housekeeping items. I will be doing the presentation for roughly 50 minutes or so. While I'm presenting, please use the chat window to post your questions online. We will be answering some of those questions as you're typing and as I'm presenting. And at the end of the webinar, we will have a dedicated Q&A to answer some more questions. And please don't forget to fill in the survey. We love your feedback. So let's get started now. Okay, say that you're a startup. You have an idea. You want to make the next Angry Birds, or you want to make the next Hungry Birds or Hungry Chickens. It doesn't always work out, as you know. You need to try a lot of different things. You need to kill off those things quickly that don't work, so you need to be able to fail fast, fail cheap, and fail forward. And you need to be able to scale with your success. Ultimately, you will need to validate your ideas. And the best way to do this is to build a so-called minimum viable product, or MVP. So what is an MVP? Basically, you want to release quickly. You want to bring your idea to market quickly, but you don't want to spend ages building it. So you want to identify what are my core features, what are the absolutely essential features, what is the core of my offering, and then release quickly with those limited core features and iterate in production, because the production is the only way for you to find out who likes your system and how do they want to use it. And then make business decisions to iterate based on actual data, not on guessing. So let's take a look at how you could implement, how you could design and then implement the core feature set of your MVP. Let's deep dive now on application architectures on the cloud. These are based on some of the best practices that we have learned working together with our customers over the years. Well, basically, you don't want to do this. You don't want to implement a tightly coupled monolithic monster of an application, or as some people say, spaghetti monster, where all the features, all the functionalities are in one huge blob. Ultimately, this will become unmanageable, unscalable. What you want to do is to decompose your requirements, features, and architecture into services, simple services that implement simple things. And then, out of these services, you will define the building blocks for your MVP. What are your building blocks? Well, I have listed some of them here. Now, this is fully theoretical. This may not make a lot of sense as an application with all these services, but these are just some examples. If you look at the bottom, you probably need compute. You need some servers or cloud instances to run things. You need storage, load balancing, maybe a SQL database, maybe a NoSQL database. You may want to have something like a social login, single sign-on system, maybe analytics and visualization, reverse proxies. And then, crucially, you need to implement your cool features, your core features. What you need to do, when you look at the previous picture, that's a lot of things to implement. You should focus. You should focus on your core differentiators. And then outsource the undifferentiating ones to services. So identify what are the ones that you really need to implement. That's my secret sauce. And just leverage services for the rest. So here in this picture we have a couple of examples where Amazon EC2 could be a service implementing compute. S3 implements object store. Amazon RDS can give you a SQL relational database as a service. You may want to use something like Jaspersoft, Puma, maybe Nginx as a reverse proxy. You get the idea. But in blue color, you would have the things that you implement with your teams. And the yellow ones are services that you outsource. So how can Amazon Web Services help? What are the services that we provide? Let's first take a look at the geographical presence. This is just a quick overview. We have currently 10 regions. Here in Asia we have Tokyo, Singapore, and Sydney. And then we have Europe, a few ones in North America and South America. A region consists of multiple availability zones. Those are clusters of data centers interconnected by low latency networking. So this enables you to distribute your application, distribute your data across multiple availability zones, multiple data centers within the same geographical region. Then you get data center level redundancy. We have also edge locations, 51 of them, where we serve out our CloudFront CDN, Content Delivery Network, and Route 53, our managed DNS services. What do we provide out of these geographical regions and availability zones? Well, on the lowest level, on the bottom of the stack, we provide our foundation services. The most foundational services are the compute, storage, and networking services. These are really the building blocks for other things in IT. And interestingly, AWS is also built on AWS. So the higher level services at AWS are leveraging the low level services like compute, storage, and networking. I'd like to highlight here, for example, databases. Everybody basically needs databases. But it's very difficult to deploy, configure, secure, backup, replicate, scale, mirror, and operate databases. That's why it may be a good idea to simply outsource running the database to a fully managed service like Amazon RDS, and then simply provision a database and use it for your purposes. We have also a range of big data analytics services. On the higher level, we have application services such as message queues, notifications, search engines, etc. And on the higher level, yet again, we have platform level services like application and infrastructure monitoring, application lifecycle management, deployment, identity and access management, etc. Ultimately, all the services that we provide are available through APIs or application programming interfaces. We have a range of methods for you to interact with the cloud. You can leverage our web console, our command line tools, and even libraries and software development kits, and directly manipulate the cloud from programming languages. No matter how you interact with the cloud, ultimately all the requests that you shoot against the cloud go through the APIs. No matter whether you click something on the web console, execute a command with the CLI, or use the libraries, for example, in Node.js, they all manipulate the cloud through the common APIs. So the AWS Cloud can give you infrastructure and platform services. To implement your MVP, you may need additional software components or software services to fulfill your business needs and requirements. So where can you discover more? For example, you can use the AWS Marketplace. That's a really handy way and handy place to discover hundreds of pre-built and pre-configured software appliances that are ready to run on the EC2 instances on the AWS Cloud. You can even deploy them with a one-click deployment. Another place to make some discoveries for handy software is, for example, GitHub, high-quality open source software. And you may also want to take a look at Netflix OSS. Netflix has started open sourcing a lot of interesting libraries and components that may be useful for you for implementing or running your applications on the AWS Cloud. Now, what are these services? What are these little Rubik Cube blocks that I have shown? Basically, a service implements only one thing and implements it very well. For example, you will need to build your cool features. You may want to consider making this a service, and exposing it to the rest of your applications and maybe third parties through APIs. And services are black boxes. You can actually iterate rapidly. You can even rewrite the internal implementation of these services. But the APIs that expose your features, they should remain relatively stable, with less changes to the API and potentially versioning your APIs so that your customers know that, okay, now they can leverage new features because the API has changed versions. So a service has black box internal implementation exposed through commonly understood and relatively stable APIs. You want to enable scalability. Now we are talking about building an MVP, so you have a chance of making this MVP cloud native or cloud ready from day one. So I highly recommend loosely coupling your application. So rather than doing this, don't connect services directly with tightly coupled links. Then the blue guy on the left, who's the client, he needs a service, a feature from the service on the right, the yellow box. What if the yellow box or service tier is overloaded or has some problems? Then the client on the left has to keep waiting. He cannot process any more requests, and he starts buffering and having a problem. You have cascading failures. It's a good idea to leverage message queues. In the AWS Cloud, we have, for example, SQS, our simple queue service, where the client can simply send requests to a queue, the queue is buffering them, and then the service on the other side can consume the jobs from this queue. With this way, you loosely couple your service components or services from each other, and you avoid cascading failures. This also enables you to scale much larger. When you communicate between services, you should leverage idempotent interfaces. And now this is not a medical condition. Idempotence means that you can retry. So the service on the bottom left wants to use the service on the top. We can see that it sent a couple of times the same request because maybe the service was busy. Idempotence means that you can retry the same command to the service several times with the fallback retry mechanism. Once the service has time to execute, work on the request, if you have tried 3 times the same request, the service executes it only once. So idempotence means that you can retry without having multiple copies of your command execution. You can also consider something called circuit breakers. This is what Netflix, for example, does in production. The idea of a circuit breaker is that if you depend on a service, but this particular service is out for the time being, maybe the service has a bug, maybe there's an outage, maybe it's overloaded temporarily, you have to make a decision. You are trying to serve your customer's transaction or request, but the service you depend on is busy. You could, for example, do this. Retry a few times, and if the service is still unavailable, temporarily bypass this unresponsive service and move to so-called degraded mode transactions. Okay, recommendation engine is not available, never mind. I need to move on with the request. I will just use a static top 10 list, for example. Keep retrying the service. In the meantime, when it's back online, enable the service again. Either move on with the transaction in degraded mode, or simply reject the transaction with a sensible error message back to your clients. Since your application or solution is composed of individual services, you can achieve much better scalability and HA, high availability assurance, by scaling, load balancing, monitoring, and HA assuring each of your services separately. What I mean by this is that, for example, if your web service tier is overloaded, you can see this by monitoring the web service tier separately, auto-scaling the web service tier separately, adding more capacity, more web server instances, without affecting the other parts of your service that may be fine. If you have a monolithic block of an application where everything is in a single blob, if one individual service within this blob has a problem, it's difficult to scale that one. So scale, load balance, monitor, and HCSR each of your services separately. I need to also mention something about state. Cloud-native applications enable scale out and scale in. Scaling out means that you will add horizontally more capacity. When you need more capacity to a service tier, you will simply run more instances that implement the functionality of this service tier. You want to avoid keeping state in these compute instances, because then it's difficult to scale and it's fragile. You want to separate the state. So what is a state? For example, a browsing session or gaming session. You have individual transactions, but you may have long-living sessions from the same user with individual transactions. So keep the data in a separate place, not in the compute instances, and keep the session state also somewhere else. Then you can simply have a load-balanced and auto-scaling pool of workers that are handling individual transactions. And the state for these user sessions can be updated and retrieved from a state management service. And the state management services need to be scalable, durable, reliable. The same goes for your data, whether it's a database or you're talking about assets like pictures, videos, etc. Keep those separate, not in the compute instances. Store your data in a scalable, durable service. So here we have a couple of examples. We have the red boxes, which are web or application servers. You can simply add more capacity for transaction handling by auto-scaling this pool of workers. And the session state and the data is stored somewhere else. For example, in Amazon S3, a simple storage service that provides 11 nines of durability, easy to use, and unlimited capacity. Then we have DynamoDB, a NoSQL database service, and ElastiCache, which implements memory caching as a service. When we talk about state management in cloud applications, I need to highlight Amazon DynamoDB. Amazon DynamoDB is really an enabler for this. It's a zero-admin NoSQL service. So it's a NoSQL database as a fully managed service. You will simply create tables, and then you will specify what is the throughput that I need for my tables, how many write operations per second and how many read operations per second. And that's it. You can go in development time from, let's say, very, very moderate 1 request per second for your table to 100,000 requests per second when you're in production. And DynamoDB has consistent less than 10 milliseconds response time for your requests. This is really interesting because it means that DynamoDB removes the bottleneck from the database. The database is typically the bottleneck and the difficult thing to scale in large scale and web scale applications. With DynamoDB, the database is no longer the bottleneck. Probably the bottleneck moves somewhere else in your application stack, but that's a good problem to have. Ultimately, what we are talking about here is finally leveraging service-oriented architecture principles. Now that the infrastructure is a set of services as well, like compute, storage, networking, etc., you can leverage SOA principles for developing your application and also requesting and provisioning capacity from the infrastructure as a set of services as well. So cloud-native applications need to be architected for automation, for scalability, for cost optimization, availability, and data availability. I'll come back to that later. And good cloud applications are always on, so they are designed for failure. If individual components fail due to hardware software failures, it doesn't take the whole service down. They have self-healing capabilities and anti-fragile design patterns. How would you implement these MVPs and these services then? Well, a really good practice is to implement them using something called 2 pizza teams. The 2 pizza teams means that the size of the team implementing the service or functionality is so small that you can feed them with 2 pizzas. Well, it depends on how big are your developers. The two pizza teams are small and autonomous. They take full responsibility for developing, road mapping, operating maybe this service. That enables them to decouple themselves from the other teams. So they don't have to wait for the other services. They don't have to wait for features in the other teams. They can continue improving the quality, features of their service and pushing them into production in an agile manner. You also want to avoid handovers, for example, from development to operations, throwing the ball over a so-called wall of confusion. So the better practice is that the team who implements is also responsible for the code. This implies trust, but why would you hire somebody who you don't trust? So let's start wrapping things up. We have now decided to outsource a lot of the services to managed best-of-breed battle-tested services, and we have decided to implement those services that are my secret sauce, our core features. How do we put these separate, disparate services back into one coherent solution? So let's start putting it back together. Basically, what you want to do is automate everything. You want to automate all the things. You have to remove the human from the equation. If you need to log in somewhere, if you need to press some buttons, if you need to execute some commands to build your systems, to start your services, you're doing it wrong. Everything has to be automated. How would you do that? How can you achieve automation? Well, AWS is a programmable platform. Since you can program the cloud, you can automate it. How are some of the ways how you can actually automate using AWS? How can you program AWS? One option is using the AWS SDKs, or software development kits. We have software development kits for various programming languages and platforms, both server-side and even mobile, like Android and iOS. So that means that you can actually manipulate the AWS services and resources directly from your application code, even from your mobile applications. Here's an example of the Java SDK. So with this command, we create an instance or server in EC2 from an image. So we request the system to create an EC2 instance of a type M3 medium, that's the size of the instance, and create it from this AMI or application machine image listed here using our SSH keys and one instance with a certain security group. So this is an example of deploying an EC2 instance directly from Java code, and it's leveraging the AWS libraries and SDKs. You can also use the command line tool. So with the command line tool, you can also manipulate AWS resources and provision instances from the services. So here's an example of a similar thing, deploying an EC2 instance directly from the command line. Now we have the unified command line where the simple command is called AWS, and you can always request help to see what options and parameters are available. So with this command, we run an EC2 instance from another AMI. Since we talk about instances and AMIs, how would you bake these instances? How would you put your stuff and your services and components inside these EC2 instances? Well, you need an AMI, or Amazon Machine Image. You can start with the default AMI, for example, the Amazon Linux instance. That's a good starting point. Then you can customize the instance if you want, for example, with your code, your application libraries, components, and then you can store it as a customized AMI. And subsequently, you can deploy EC2 instances from your custom images. There are a couple of different ways to do this. Some people prefer creating fully pre-baked images. A pre-baked image on the left means that everything required to run your application is part of that image. So you simply launch EC2 instances. They will automatically start services required like web servers, application servers, etc. with all the correct configurations, and all the binaries are already there, including the operating system, application support, middleware, libraries, and your code. Then you don't need to orchestrate anything, you simply deploy more instances. The other option, what some people like to do, is to take a base image. On the far right, somebody wants to just take a base operating system image, let's call it a JEOS, just enough operating system image, which simply implements a certain operating system. And then they may want to orchestrate the correct versions of packages required to run your application, like maybe Apache Web Server, Nginx, Java, etc., and your code. From where? Download it from repositories and version control. But you need to automate this, so you need to use orchestration tools. It depends which way you prefer. Both of these work. Some people prefer the one on the left. Some people want to orchestrate more, as in the right. How do you orchestrate things on your EC2 instances? You can use the tools provided by AWS, or you can also use several third-party configuration management and orchestration tools. Here we have a few really popular ones, like Ansible, Chef, Puppet, and Salt. These are handy tools to help you have reliable configuration management and orchestration of your packages and your configurations. You simply give the tools a target that your instances should reach, and then the tools will fulfill the steps necessary to reach this target state and keep it at this target state. You can also use AWS tools. So we have services that can help you manage the life cycle of your applications, including the orchestration and automation aspects. So what is the life cycle of the application? You need to deploy your applications. You want to do upgrades, production upgrades, maybe downgrades, undeploy, etc., and handle the configuration management at the same time, and things like monitoring, etc. So we have different services. On the left, we have AWS Elastic Beanstalk. That is the most convenient way for you to consume the infrastructure. With AWS Elastic Beanstalk, you simply want to focus on coding your application. So Beanstalk lets you focus on coding your application, and then basically you take your application, you throw it at the cloud, Beanstalk catches it, and it builds the infrastructure underneath to run your application. It runs it in containers for different languages, and then fully automates building the infrastructure underneath. You can have a single instance to save cost in development time, or you can switch to a fully load balanced and highly available environment fully managed by AWS Elastic Beanstalk. That is the most convenient way for you to focus on your application development, which is your differentiating action. On the far right, you have do-it-yourself, where you provision all these different services that you need, like EC2 instances, EBS volumes, S3 buckets, maybe Elastic IPs, etc., and you write the glue, you put everything together. Then you have full control, but also you have to maintain all this code and functionality that handles the management of the infrastructure. In the middle, we have AWS OpsWorks. AWS OpsWorks gives you more control than Beanstalk. It lets you use a really handy and nice graphical user interface in the web, but it gives you more control than Beanstalk. You can basically compose your application out of different stacks that implement different services and features. It's a DevOps framework that supports continuous integration and deployment really easily. So please take a look at AWS OpsWorks and go through the tutorials as well as the other services that I highlight here. AWS CloudFormation gives you even more control. CloudFormation is what I like to call infrastructure as code. With AWS CloudFormation, basically you have a template, a JSON template, which is a text file or a piece of code. With this template, you can describe an entire system on the AWS cloud as a piece of code. And then you can store this in version control, and you can update the template in production to change your system to the next version of your system. So you have different options. You can use different tools, and I recommend that you get familiar with these different tools. Here's an example of AWS CloudFormation. So with this single template here, one can describe the entire system on the right. So you can describe an entire complex architecture leveraging several services with your custom applications and code, all orchestrated with interdependencies, automatically built and managed by CloudFormation when you require. So deploy an entire system out of this single template. The system could be, for example, this. You could make your development and testing environment fully in the cloud. So you could deploy this system, build it first, and then store it as a CloudFormation template, and then you can deploy an entire copy of your development and testing environment in the cloud when you need it. So you would have here, for example, your source code repository, your continuous integration server, maybe something like Jenkins, your project management server, maybe bug tracking like Jira. You need a database, that could be Amazon RDS. And then your continuous integration server would be executing your regular test automation. So executing your integration tests, your unit tests, and successful testing would result in software builds. And then you would be storing your software builds in Amazon S3, which gives you 11 nines of durability, and you don't have to worry about capacity management. So you can have your entire development and testing and continuous integration system in the cloud. Once you start producing your builds out of this system, you can move to the next step, where you can leverage CloudFormation again to deploy your application into the cloud. So by describing your application in a CloudFormation template, you can simply deploy a complete system in the cloud that runs your application with the exact infrastructure required to run your application. So that's the system on the right. So you would have here, for example, a domain name managed by Route 53, for example, a load balancer receiving the traffic, an auto-scaling group of EC2 machines implementing your application, and maybe an Amazon RDS or DynamoDB database in the backend. This entire system can be deployed automatically by your systems leveraging CloudFormation or the other tools that I mentioned earlier. What is the interesting thing here is that then you're version controlling not just your application, but you're also version controlling the infrastructure required to run your system. So now you can version control both my application code and the infrastructure description to run my code. That enables you to deliver continuously. By delivering continuously, you deliver value to your customers in the form of new features when you iterate your product, or bug fixes to quickly bring fixes to your customers' benefit. So leveraging things like infrastructure as code, and everything is now programmable, you store your application code and your infrastructure description in version control. You must have full test automation for unit tests and integration tests, execute the tests rapidly and quickly, often, and then deploy to production. Basically, as you deploy to production more quickly, you reduce the size of your deployment. You reduce the number of code changes that you bring to production. This is reducing the risk and size of your deployments. By deploying quickly, you also then bring value to your customers more quickly. And there are a couple of best practices here as well, or development processes. If you only do agile development in a Scrum team, that's fine. You do your planning, your Scrum planning, your coding, and your building in an agile development. However, if the Scrum team is throwing the new piece of code rapidly to the testing and operations team, and the testing team is using legacy ways of managing the infrastructure, it just doesn't work. It falls flat. They are not agile actually enough. By moving to continuous integration, you introduce full test automation. So this is improving things. Your system can automatically run the test cases for all the new builds. By moving to continuous delivery, you can rapidly bring value to the market by deploying successful builds quickly to production. And then finally, currently the understanding of the best practice end-to-end is something called DevOps, where the development team and the operations team may be even the same team. So in this case, the two-pizza team would be coding and developing the feature, and then deploying it to production and supporting it in production as well. Or the other option is that your developers and operations team, they both enjoy full automation, they work hand in hand, they actually collaborate more, they don't throw things over the wall of confusion, they work together, and this is adding value. So as you move right on the chart, you increase the collaboration between your teams and your individuals, and you increase the value as well. By being able to deploy continuously and being able to deploy automatically your system into production in the cloud, you can also leverage the global nature of the cloud data centers and regions. So you can go global with your product in a matter of minutes. So what you could do is launch your MVP in a test market, maybe do A/B testing to see how to iterate, what features to improve and build. All the information how people want to use your system are in the log files, so you need to collect all the log files, analyze the log files, you get insights, and then you iterate. You have a feedback loop back to your product team. Once you hit the sweet spot in the target market, maybe your test market, you can simply copy-paste your entire system as infrastructure as code and deploy it to other markets globally and expand your market size like this. So here's an example of an A/B system in the cloud. It's rather simple. So the system on the left is deployed from a template where there's one change. Maybe you have added a new feature, feature A. System on the B, the right-hand side, is otherwise identical, but it has a different feature, feature B in production. Using, for example, Route 53 and elastic load balancing, you can send half of your customers to system A and half of your customers to system B. Then you would collect all the log files, store them in S3, and then analyze the log files. Because the log files tell you exactly how people like to use your features. Are they able to proceed to the functionality you wanted, or do they drop off? They get bored. You will want to measure and log everything. If you don't instrument and measure your system both for operational and business reasons, you don't know what's going on. You're driving blindly. So leverage things like Amazon CloudWatch and monitor and measure everything. And when you measure something, don't just look at the average. If you look at a KPI and you look at the average value, all you know is that half of your customers or half of your system is worse than the average. That doesn't tell you too much. Use things like histograms, for example, and then focus on improving the worst case scenarios, for example, the worst 1%. As you improve the quality of service and experience for the worst 1 case percentage, you move the whole bell curve. Everybody benefits. I mentioned collecting log files. So in a large system, you may have a lot of log files to analyze and a lot of other data to be produced and needs to be analyzed. So rather than building big data systems by hand yourself and then operating and managing them, it's a good idea to leverage best of breed, easy to use big data services. And we have a range of big data services in AWS for collecting, storing, analyzing, and sharing data, both for real-time and for offline analytics and different use cases. But that is a topic for a completely separate webinar. Ultimately, you will want to keep iterating. You want to keep innovating. And if you want to innovate, you need to be able to lower the cost of failure. By lowering the cost of failure, that enables your teams to experiment, which breeds innovation. The cloud lets you fail fast and cheap and scale your success. You will be able to experiment often because the cloud brings the cost of failure down to zero. Now, let's move to the demos. I'd like to show you a couple of things which hopefully validate some of the things that we have been talking about here. Let's first use AWS Elastic Beanstalk, the easy-to-use container service to run applications. Let's do a production upgrade using Git integration. The second demo will be on AWS CloudFormation. We can do a production upgrade of an already deployed template or entire system. So let's see how we can upgrade running systems with CloudFormation. And the third demo is more low level. Let's see how we could program the cloud. For this one, I have chosen the Ruby SDK. So let's use the Ruby SDK to control the DynamoDB NoSQL database service and to deploy an RDS relational database. So now let's move to the demos. I'll bring up my browser. Here we go. So the first demo, just move my windows here slightly. The first demo is on Elastic Beanstalk. I have already deployed this application. I can show you the events. So I started deploying the application this morning at 10:16. And moving up at 10:29, which is about 13 minutes later, this system was launched. This is one of our example applications, which is using Ruby 2 and Passenger to run this system. So Elastic Beanstalk has the container to run my Ruby application, and it has built the entire infrastructure underneath automatically, including the database and EC2 instances and load balancers, etc. And the system is currently running happily. You can see it's green. If we click on the link here, we can access the application. So now we have loaded the application. We are accessing it over the internet. And you can see it's a kind of a marketing website implemented with Ruby and Passenger. So it says currently something super duper cool is coming. Let's make a production update. So here in this command line window, here in this terminal, this is the directory from where I deployed the application. We can also use the command line tool for Elastic Beanstalk called EB and check the status. Currently, the command line tool is reporting the same, that the application is running and it's green. And there's the pointer to where the RDS database is for this particular environment. So let's make a production update. Let's change the text here from super duper to something else. So what I need to do is edit the code. So let's find and edit the index.html in this Ruby code. So I have opened this in the editor here. And let's find the super duper. There you go. So near the top on the third row we have super duper. Let's change that text to hyper diaper. Probably not proper English, never mind. So we make a simple code change here. I save the changes. And then let's do something. Let's git status. Now Git is telling us that we have made a code change. So we need to add the changes and we need to commit the changes. Changed title string. There. Now the local Git repository and version control is happy. We have committed the code changes that are made to the index file. And now to deploy this code change into production, all I need to do is execute git aws.push. So directly from Git, I can now deploy the latest version of the code into production. So in practice, Git is now communicating with the Elastic Beanstalk container service, uploading the new version of the application to Beanstalk. Now you can see in the background in the console that Beanstalk is now updating the application. It's receiving the packets from Git with the new version of the application. It's updating it in the container within the EC2 machines, all of them that are running. And then after a short while, the update will be complete. And then we should have made a production upgrade. But we need to still verify. So this particular environment is load balanced and auto-scaling. It has an ELB, Elastic Load Balancer, in front. And you can have multiple instances of EC2 running in the background implementing your service. And then this system can respond to load changes by adding more instances when needed and then removing them to save cost when the load is less. We can also monitor the update using the EP tool, EP status. You can see it's updating. You can also execute verbose to get some more information. So for example here, you can see that the database backend is a MySQL version 5.5 running in a micro instance. So soon the update will be complete. I can show you some other things. You can see events. You can see that we are deploying the new version to our instances. We can also look at log files. So I can show you how, in the meanwhile, we can snapshot the log files. So if you need to troubleshoot your system, you can either log into them if you have used your SSH keys, or you can snapshot the most common log files using the console, and then simply, once you have requested them, you can view them here directly in the console. But obviously, if you need to do more low-level investigations, you would log into the system using your SSH keys. Now the update is complete. You can see that the system is back to green status, and it's running again. So let's access the application again. I again click on the application URL link here, and now we can see that we have updated our application in production. Because this was a auto-scaling and load balance system, Elastic Beanstalk updated the instances one by one in a cascading fashion. So now we have done a production upgrade using Elastic Beanstalk. So with Elastic Beanstalk, all you need to do is focus on your coding, and the infrastructure is automated. Very handy. Let's move to the second demo then. The second demo is CloudFormation. So here we can see the CloudFormation console. You can see that I have already deployed an application. This is one of our default templates. It's a WordPress running in a multi-AZ environment. So when we look at this history here, we can see that I started creating this stack at 10:34 this morning, and then create complete is somewhere later, here, 10:52. So roughly 15 minutes or so later. This one also has a database. So it's running in production. We can go to the outputs here, click on this link, and access the application. You can see that it's running WordPress. But you can also see that the URL, which is automatically coming here, is dynamic by nature. So if you don't specify any domain name, then it will have a dynamic domain name automatically assigned to it. Nobody really wants to use in production this kind of a randomly assigned dynamic domain name. So what I have done is that I have edited this template. Let's take a look at this template now. So I open this template in the editor, and I'll show you what I have done. I have added a Route 53 configuration to this CloudFormation template. So with this configuration here, I have assigned a domain name to the system. So let's go to Route 53 and take a look. Is it there? Yes, it is. So this domain name has been automatically populated by CloudFormation. So the domain name or host name is www.markku.co, which is the domain that I have registered and allowed Route 53 to manage. Let's now do a production update to the system using CloudFormation. Let's change the host name from www to something else. So we go to the code editor, and you can see here the Route 53 configuration, and you can identify here the string www. Let's change this to my app. My app. I press save. So I have made a code change. I have saved the changes. We go back to CloudFormation, and we click on Update Stack. We want to upload the modified template, this one here. Click on Next. So now I'm doing a production update or upgrade to a running system. Database password. No changes needed there. So the other values are populated by the template directly. So we have done one change. We changed the host name from www to something else. Now I want to update the stack. So basically I'm sending another version of the template to CloudFormation. CloudFormation identifies what has changed. Okay, he has changed one thing. He changed the domain name here from www to something else. That is a change that CloudFormation will now manage in production. So when we refresh the system now, we can say that CloudFormation is updating the system, and you can see that it's manipulating a resource called Route 53. So now when we go to Route 53 and we refresh the page, parang, Now you can see the application's hostname changed from www to my app. So that was a quick demo showing how you can use CloudFormation not only to deploy systems, but also to update them and bring changes in production. And you would, of course, version control them. How do I version control my CloudFormation? Like this. I executed a git command. I've integrated my applications on my laptop so that the diff tool that Git uses is this graphical tool that I use here. So I have asked Git to run a comparison in the local repository for my CloudFormation scripts. And so, what changes have I made for this template? You can see them here. For the WordPress template, the one on the left is the latest version. The one on the left has a domain name configuration. And the version on the right is the older version, which is the original template that does not manipulate host names and domain names with Route 53. So this is infrastructure as code. With this code change, I have added a domain name to my system, and I'm able to version control this and deploy versions of my infrastructure into testing or production. So the final demo I'd like to show you is quickly using Ruby SDK. I'm running Ruby 2.0 now in my laptop. Let me make the window slightly bigger. I happen to be using CH Ruby on my laptop to manage the different Ruby versions. And then, if I execute gem list grep AWS, you can see that I have installed using gem the AWS SDKs for Ruby. To execute the Ruby SDK in interactive mode, I can simply execute aws.rb. This is an interactive console for the Ruby language using AWS libraries. So what can we do here? Well, we can, for example, instantiate services like S3 or RDS and get them back as objects. What we can also do is execute a command called service classes and see what are the AWS services that I can actually manipulate directly from Ruby code. So here we have a list of AWS services, and this is all in GitHub. And you can also find the documentation to what parameters, what commands you can use, what methods you can call for what services. So everything is nicely automated and open source as well. So let's execute a couple of commands now here. Let's simply ask DynamoDB, what tables do I have in my DynamoDB? So in the Singapore region, which I have configured as my default one, I execute dynamodb.listTables and I get back a response. There is a table called Ruby demo. To see better what's in that table, I can execute response equals DynamoDB describe table, and we get the response back. We can also make a hash out of the response. There you go. Now, the actual demo I wanted to show you is to provision resources with the AWS services directly from code. So let's do one more thing here. Let's deploy an RDS database directly using Ruby code, leveraging the libraries and this SDK. So I have here a command which I have obviously written earlier. RDS create database instance. Let's give it a name from Ruby SDK with 100 gigabytes of storage running on a db.m3 large instance with the MySQL engine and username and password. Those are the minimum required parameters that you need to fulfill. Let's execute this command directly from the Ruby SDK, and then we get a response back. You can see here that the database instance status is creating. And to finalize the demo, let's now go back to the console. Let's go to RDS and see, do we have a new database instance coming up? We need to go to Singapore and look at my RDS database instances. And yes, here we go. We have a database named RDS from Ruby SDK being created. So that was the demo of manipulating AWS resources directly from code, leveraging our SDKs. Now, I'd like to thank you for this. We need to move on for a few minutes to the Q&A. This is the URL that I have highlighted for you, aws.amazon.com/activate for Activate Program for Startups. Please don't forget to fill in the feedback form. We love your feedback. That lets us iterate rapidly in production and improve our services for you. And now let's move to the Q&A. Peter, do we have any questions for myself?
Yeah, we have a number of questions. Let's start with an interesting one. I think your Beanstalk stuff has been interesting to some people. So, Markku, is there a downtime for the application when I update and push code to Elastic Beanstalk? Is a question we got in.
Very good question. If you're running a single instance, yes, because the container will take the application out of production, change the application with version in the container, and start it again. So there's a stop, update, and start. However, when you use load balancing and auto-scaling, it's going to do it in a round-robin fashion. So if you have more than one instance, then it's going to do it one at a time on those instances. So that's better in production.
Okay, and maybe to some extent related to that, like someone asked about any system performance issues during an update from Git. Are users being affected, or how do you run that?
Well, it depends what you do. So if you refer to the Elastic Beanstalk, no, not really, because the Git update is what you would call management or control plane operation. So it's very lightweight operation where Git is simply contacting the service, Beanstalk, saying that, hi, I have a new version of the application for you to run. Beanstalk is going to take it. It's actually storing the new version in S3 as well as a second version control and storage system, and then it's going to execute the update. But these management operations are done by the service itself, Elastic Beanstalk, not by the production system. So for your production instances, all that's going to happen is a download of the new version of the application within the container and then restart the services, for example, maybe the web server application server. So the Git itself is not a heavy operation.
Okay. Another one, someone is interested in understanding how they can improve application performance with a load balancer service, with ELB, Elastic Load Balancing.
Yeah, that's a very good question. It's a really valid question in cloud computing. If you don't run a load balancer, you would be sending all of your traffic to one instance of your service tier or your application, and that doesn't really scale. It can scale vertically. So if you have a single instance running your application, you would probably have an Elastic IP and a host name mapped to it so that you can access it. With vertical scaling, you can change the size of the instance to a stronger virtual machine with more CPU, RAM, or memory, or I/O disk capacity. But ultimately, you will be using our largest instance size, and if you need more capacity, then you have a problem. So the much better way in the cloud is to identify first the right size of your EC2 instance with enough resources to run your application. You need to monitor your system. How much memory, CPU, I/O am I using when I'm running at full capacity for this instance? Right size your instance, have enough resources, but not too much resources, because then otherwise you pay too much. So optimize the size of the instance first. And then scale out means that you add more instances to implement the same service. Then you need a load balancer in front to balance the load and incoming requests to healthy instances in your pool. And each of those instances are identical, implementing the same service from the same binaries, same configurations. And as I mentioned, the state is then something you need to manage. Don't keep state, don't store data in your instances. Otherwise, you have a problem if the instance goes away.
Okay, great. We have some questions as well. Questions we get a lot from enterprise customers, but our security is always number one, regardless of whether you're an enterprise or a customer. So when you think security as a whole, Markku, when you think about DDoS and you think about other things, can you share a bit more about our view to security to answer that question?
Yeah, absolutely. Very valid question, and something that you have to keep in mind and design for and test properly. So first of all, we have a shared security model where the AWS infrastructure and platform itself, we have a lot of security accreditations, certifications, processes, and tools to make sure that the AWS infrastructure and services are very secure. Security is our #1 target. That is for the infrastructure side. The second part of shared security means that you as a customer who leverages the cloud utilities and services, you need to secure your own workloads on top. We can help you with that. We have things like security groups, which are fully programmatically controllable firewall rules. VPC, Virtual Private Cloud, lets you programmatically provision and isolate a part of the cloud only for yourself with your own IP address ranges, your own firewall rules, routing table rules, etc., and security groups for those instances. You shouldn't use plain text usernames and passwords. You should use public-private key security for manipulating the resources. You should leverage our identity and access management for having groups of users with granular control on who can do what. For example, developers can only access the development system. Operations people can only manage the system in production. Managers can only see things, they cannot stop anything. So using IAM, you can give granular access control to different groups of people. That's basically, the whole point is this. Because the cloud is programmable, you should also design your security to be built into your service and application so that when you deploy an application, it programmatically brings the security with it. So lock down everything, deny all by default, dynamically allow access only between those clients and servers who need to talk to each other, authenticated by public-private key pairs, programmatically correct firewall rules or security groups when you deploy the application. There is no more excuse, in the words of Werner Vogels, our CTO, there is no more excuse not to design applications secure by default.
Yeah, and to add to that, is there anything you can share in terms of references or credentials that show how many people trust the security of AWS in the type of workloads they're putting on us?
Yeah, absolutely. For example, NASDAQ is running the FinCloud financial platform on top of us. We have very large enterprises, for example, Shell, Nokia, Ericsson running production systems, Samsung on top of the cloud. So they have all done security analysis, and we have fulfilled all of their requirements. And then the really nice thing is that, like Peter likes to say, my colleague here, is that, well, you can write on the giants. How do you say it, Peter?
Say again? The
giants?
Oh yeah, this concept of standing on the shoulder of giants, and
yes, exactly.
The way to look at that is you solve for, the way we look at it is you solve for one, you solve for all. So if you're a media company, a startup in media, and Netflix is a very large customer, we have a number of large, for example, in India, Hungama and Eros and a couple of others. If we solve their problem, if we listen to them and develop solutions and features for them, you automatically get the benefit of that. If we work with CIA or with the U.S. government or with NASDAQ and other financial institutions, and they have specific security requirements, we build it for them, but we solve for you as well. So you get a lot of benefits out of us developing for our largest clients who have the most stringent requirements. So
exactly. All of our customers.
We're almost running out of time, but there's a bunch of very good questions in there. So I'll try and answer a couple of those one-on-one. But let me see if there's some like one or two final questions that we can take.
Absolutely. Thank you, Peter.
So someone asked about these examples and demos were all Linux. So we have some questions around whether we can do that for Windows as well. So I privately answer that yes, all of this is available for Windows, and the demos actually do not change really when you run it on Windows. There's a question around a load balancer that you talked about earlier. Can we configure a load balancer for something like a sticky session in case of multiple instances? Is that something
yes, you can. Yes, you can. So you can use, for example, load balancer assigned cookies. You can have application assigned cookies. You can set the cookie expiration time, etc. So yes, we have those features in the Elastic Load Balancer.
Okay, and then we have one very specific question, but I think we can also take a step back from the specifics. There's someone asking. He's saying that he's planning to create a multi-tenanted application for geospatial. Do you have any references on how you can plan, design, and build the minimum structure for a geospatial cloud? Now, I won't go in answering that, and Mark will add to my answer if you want. I won't answer this question in detail, but whenever you have questions specifically for use cases, if you go to aws.amazon.com, there's a whole range of use cases there that you can learn more about. There is a so-called architecture center where there's reference architectures for all sorts of applications. So you're building an e-commerce site, you want to know what does good look like, what are the best practices in building an architecture. There's actually a reference architecture for e-commerce. There's a reference architecture for mobile apps and web apps. There's an architecture, reference architecture for gaming and things like that. So there's a lot of information you can find there. What I also found valuable is we have a whole section on aws.amazon.com that is case studies. So for example, for geospatial, Esri, which is one of the largest provider of geospatial services and platforms, is a large customer and partner of Amazon, and there's a case study, if I'm not wrong, on Esri. So whenever you have these specific questions for certain use cases, go to aws.amazon.com, look at the architecture center, look at the solution center area where you can look specifically at how you use AWS for your specific use case, and look at customers or companies that are similar to yours. Basically, sometimes you can just, in this case, just do a lookup on geospatial, and you'll see all sorts of use cases for people that have requirements there. And one example here, for example, geospatial is Instagram that is using Postgres on EC2 for the geospatial features and their geotagging of the pictures, for example, that all runs on Amazon. So that's maybe to some extent an answer to that one. With that, I think we come to the end. Marcus, since you've been running this webinar, maybe you can have some final remarks and close it off.
Yes, absolutely. So first of all, big thanks to Peter, and especially big thanks to everybody who joined. We really, really enjoy your questions, and please give us your feedback. It will help us iterate, and we plan the next webinars then based on your feedback so that we know that you actually like what you deliver, and we try to always meet your expectations and exceed them if we can. So thank you very much from my side again. My name